So we can fine. So let me share my screen and then we will proceed. Okay, first, this is what I want to do.
So we are doing data visualization. Yeah. Oh, what? Plot historical complexity box scatter.
I need.
Yeah.
Okay, so good morning, everyone. Welcome to day 4 of the training. So today okay, I usually like to recap. So we've in the past few days gone through steps in data management process. We talked about Mike, let's list it. The steps of data management. Okay. The steps. Bash.
That's the version. You mean first that's the version. Cleaning, summarizing.
No.
Yeah, just cleaning. Yes, summarizing.
Manipulation.
Manipulation. Summarization. Visualization.
Analysis. Good. So today we are on the 5th one, which is the data visualization. That's actually the most glamorous part of data management process. That's when you begin to see evidence of your work. Okay, so first of all, before we go into our environment, I want us to look at how do you decide what plot to use for what kind of variable. So in summary, basically, we know there are broadly 2 types of data. We know that we have the numerical and we have the categorical. So if you have a single numerical variable, usually you should plot a histogram or a density plot or a box plot. So these are used to visualize a single numerical variable. If there are 2 numerical variables, you usually use a scatter plot. Then if you have 1 categorical variable, you use a bar plot, bar chart. If you have 2 or more categorical variables, you use still a bar chart, but specifically use either a stacked, a grouped, or a percentage bar plot. We'll see what this means in a short while. And then if we are dealing with 1 numerical and 1 categorical variable, we use a density plot. If we're dealing with 2 categorical variables and 1 numeric, we use a density plot, and then we use a function called facet wrap to define the categorical variable. And then if we're trying to visualize 2 numerical and 1 categorical, we use a scatter plot, and then we use color to categorize the categorical variable. So that's basically a summary of how to visualize, knowing what plot to do with what type of data. Okay, so having said that, let's jump into our studio. Okay, yes, I will share it. So visualization, the package used for visualization in R is the ggplot2 package, which has the ggplot function. And basically, whatever visualization you want to do, whatever visualization you want to do in R, using ggplot, R expects 3 things from you. And those 3 things are what we call the grammar of graphics. Once you're able to understand the grammar of graphics in R, you can plot any graph, any geometry you want to plot. And those 3 categories of the grammar of graphics are, number 1, we have data. Number 2, we have mapping. Number 3, we have geometry. So once you are able to feed these things into ggplot, you can get whatever graph in R that you want. Again, data, mapping, geometry. So let's look at them individually. First is the data. Just like we've been doing all this while, before we start anything, we tell R what data sets we're trying to work on. It's the same thing here. So data is to tell R what data set you want to work on. So that's simple. Then the second one is mapping. Mapping tells R what you want, how you want your coordinate space to be, the canvas. If you look at this plot here, let me zoom in so we can see. Now, this rectangular ash-colored object, that's the coordinate space. That's where you tell R, what do you want to place on the x-axis? What do you want to place on the y-axis? How the scaling is going to be? Just this space, that's the mapping. So in this space, you can tell R what you want on the x-axis, what you want on the y-axis. You can tell R, additionally, if you want to, for example, if you look at this, let me remove this here. If you look at this side, we see awake is a variable. We told R to categorize or to reflect awake in this place by size, or sorry, by is this color or shape? No, it's size. Size, I think this is size. We asked R to represent awake by size on the canvas, and we asked R to represent sleep total, which is also a variable, by color on the canvas. So all these things that we told R to do are what R expects to see in the mapping. You can see if we remove this line and these dots, the mapping will be, this place will be empty. And that's how the canvas appears before you now put in the last one, which is the geometry. The geometry now tells R exactly what diagram you want. Do you want a bar chart? Do you want a histogram? Do you want a density plot? Or do you want a line plot? Whatever it is, that's what the geometry is. But the mapping defines this coordinate space and then characterizes variables according to the x-axis, the y-axis, and certain other parameters. So let's go back. So those are the 3 pillars of the ggplot visualization pattern: the data, the mapping, and the geometry. So let's begin to see how to apply these three things in this. So we will use, for this first part, we will use a data set called BOD. View BOD. It's also embedded in R, so you can get it on your system. So if I click Control Enter, so this is our BOD table. It's just a table of 2 variables and 6 observations, showing variable time and demand. It shows as time is increasing, the demand of, I don't know what this is, but as the time is increasing, the demand for it is also increasing. So that's what we're working on. And you can see what kind of variables are this, what classes of variables are this? Numerical variables. So let's go back to our list. So now we want to plot. So for 2 numerical variables, we said it's a scatter plot that is best used to visualize them. So we say ggplot, we start in brackets. We tell R data equals BOD. So we have done the first step, which is this data, comma, we go to the next. We say mapping equal to all those things I described that are in the mapping, the x-axis, the y-axis, and all those things. They are all aesthetics, visuals. So you need to write AES, which is aesthetics. Open up your brackets, and then what mapping wants to see first is what's on your x-axis. So you tell mapping x equal to, and the x-axis usually has the independent variable. So in those 2 variables, time and demand, time is the independent variable. So x equal to time, comma, y equal to, so after x, mapping wants to know what is on your y-axis. So y equal to demand, right? Okay, so we've defined data, we've defined mapping, right? Then, you know, if this was in tidyverse, we will use at this point a pipe operator. But in ggplot uses plus as its own and then. So we go enter. And then the next thing we said is after data and mapping is the geometry. And geometry is where we tell R what shape of object we want to plot. So the function is geom underscore. So we said a scatter plot. So that's geom point. And then this. If we run Control Enter, if you run this command, you can see it has plotted time on the x-axis. It has plotted demand on the y-axis. And now we now have the scatter points, the points of corresponding time and demand like that. Let me do something. If I run the command at this point, let me remove this plus. So we've not, let's ignore this one first. If I run the command at this point, just with data and mapping, you can see it just defines the coordinate space for us. So it just assigns the time, the x-axis, it assigns the y-axis, and then gives us an open coordinate space. So that's what mapping does. So, but when you now include the geometry, that's when the object now comes onto the map. So I'll get that back. Backspace, and then we'll add our plus here. So when we run this, we get back this. But this doesn't look very, very aesthetic. So we want to improve it. So we can say we want to add a line, let the line join this plots. So put in our plus, just like in tidyverse, you put your pipe operator here is plus. and then you do geom line, and then we run this. So you can see, so it has added line to the plot. So data first, mapping second, geometry third. Once you do these three, there's no graph in R that you cannot plot. These are the three foundations of data visualization in R. Every other thing is just additions to beautify your graph or something like that. So let me show us a few beautification. Now, these points, they look a bit small and their default is 1. So I want to increase the size of this point. So I go to the zoom point and I tell it, increase the size to 3. And we run the command. Where are you? Control enter. Okay, good. So you see the size of the points have increased to 3 times what it was before. Now, the color, yes. So I don't like the colors of this. I want to make the color of the lines look a bit better. So I go to zoom line and tell it, I want the color equal to red in inverted commas. I run the command, and you can see it's changed the color of the lines to red. So like I said, every other additions you do will be just to beautify your graph, but the basic foundation is just using data, mapping, and geometry, and you get your graph. Okay, let's move a step ahead. Now, I'll do this same thing. Copy, paste. Now I said our 3 components are data, mapping, and geometry, right? Now, once you write ggplot, the first thing it wants to see is the data. But you don't actually need to write data equal to. You can just remove data equal to and just write the data set there, because what it's expecting is the data. So you just write data. You don't need to write data equal to. Next, it expects the mapping. So you don't actually need to write mapping equal to. You can remove mapping equal to and just write aesthetics. So this simplifies our graph. If let's change this color to blue so that you'll see a difference when I run the graph. Blue. So if I run this command, see, it's the same thing we produced. The only difference is I've changed the color of the line to blue, but it's the same thing. So if you look at the So if you look at the first code, it had data equal to BOD. Second code, we didn't write data equals, just BOD. This first code had mapping equal to. Here we didn't need to write it because R already expects that that's what you will type in. So you just write that. Let's take it to another level. So we now enter into the tidyverse package distance. So since the first in tidyverse, we first tell R the package we're using, the data we're using, we can just say BOD and then pipe in operator is back. ggplot. So now, since we've already told R from the beginning, we're using the BOD data set, we don't need to repeat it again in this first ggplot because it already knows that's what we're working on. So you can just go ahead from here and do your aesthetics. Yeah, good. Now, also, once you do aesthetics, R expects that the first thing you're going to tell it is what's on the x-axis. So you don't need to write x equal to, you can just write time. It also expects that the second thing you will tell it is what's on the y-axis. So you don't need to write y equal to, you can just write demand. And then we put in our plus, and then we put in this same thing here, this line, copy and paste. So I'm going to change this so that the graph will look different, and we appreciate this. I'm going to increase the size of the points to 7, and then I'm going to make the color of the line green. And I run this command. So you see, we've increased the points more, so 7 times what it was before, and then the line is now green. But what I wanted to just show us is bringing it into the tidyverse environment with our pipe operator. But the ggplot still continues to use its plus. And why this is good is because, you know, if you use ggplot and you write the data here, sometimes you might need to manipulate the data before you pipe it into ggplot. For example, let's look at this. Let's say I didn't want the times 3 and 4 to show. So I come here, BOD, so we filter out where time percentage in percentage C 3 4, and then we pipe that to.
Do we have any shortcut for that percentage in?
No, this is a shortcut.
Oh, no, I mean keyboard shortcut.
No, I don't know the shape for that. Okay, so you see, we have worked on this data BOD by doing this filter before we pipe it into ggplot. So you can do a lot of things on your data before piping it into ggplot, and ggplot will receive whatever manipulations you've done above into it and use it to plot your graph. So when we run this command, no, I wanted 3 and 4 to go out, so I needed to put minus here. Sorry. Control Enter. Where are you? Control Enter. But it's not supposed to be blank. Yeah. Yes. No, but it doesn't show any error here, so it means it's supposed to run. Okay, no, value is done with quotation mark. Let's use 1, 2, 5, and 6. See, which is the same thing. Okay. So what I just wanted us to introduce is that we can work on the data, do several, you can mutate, you can do whatever thing you want to do before piping it into ggplot, and that's the beauty of using the tidyverse. If we didn't do this here, we'll need to come down and do ggplot data equal to filter, filter, and then BOD $, time, what is it called? $, you know, we just, it looks messy, but once you use your ggplots, everything comes out neatly. You just work on your data first before you pipe it into your ggplot.
I have one question.
Yeah,
So
please.
when you were like, if you wanted to put like a minus sign before C because you wanted not to take those values.
Yes.
So if you can use it like the minus, and I saw that there's last time you were using that exclamatory sign to figure out something.
Exclamatory sign, yeah, means opposite. This that's this thing. Okay, that one is exclamation mark means not equal to. Not equal to. Let me show you where we can use. Let's say BOD operator, filter, time is not equal to 4. Control Enter. So we said here time is, this is the exclamation mark, so it's not equal to. So you can see in the console, it has eliminated 4 from the time. We only have 1, 2.
Like if I want to select, it's not equal to 4 and 5, so 4, 5.
No, you have to do it individually. You have to do time not equal to 4, comma, time not equal to 5. And then Control Enter.
So you wanted to do this with
So,
the
but if you want to do
same-
4, 5, you need to put them into concatenation so that they can link them together.
And then when you
Concatenation.
you have to put minus.
No. Yes, you have to put minus to say you don't want those 2. Yes.
Is minus work on filter? I thought minus only works on select and deselect.
On select, right?
Yeah, so
Okay, yeah, maybe, I think so.
Yeah, when you put minus on filter, what does it mean? Is it the filter?
I think so. I think select minus works on select.
And that's why it's used when you just first try or you just get.
Yeah. Okay. So we move ahead. Thanks for that, Vash. Now we move into plotting.
4 and 5.
Time not equal to and time. Okay. So it removes the 4 and the 5. So you now have 1, 2,
Yes.
3. So this is 1, 2, 3, and 6.
7.
Right?
1.
Okay, and 7. 1, 2, 3, and 7. Yeah. Okay. So fine. Let's move ahead. So let's look at how to plot those different categories: are single categorical, single numerical, double categorical, double numerical, and all that. So we're going to be using the MSLIP data set.
Will you send it to us, Mrs. Phillips?
Yeah, I can send this one. Okay, so that's the
that chart you created, which table for
okay, I'll send that and this. Okay, so this is the MSLIP data set. It has categorical, it has numerical variables. If we want to know, if we talked about our what is it called now? Untitled. Okay, we talked about scheme yesterday. So we can use scheme to view this so you can have a summary of what it is. Okay, so look at the M-sleep. Okay, so it has 83 rows, 11 columns. It has 5 character variables and 6 numerical variables. So that you can play around with. So we know it has both categorical and numerical variables. Okay, so let's look at single categorical. So in that data set, M-sleep, var is one of the variables. Do you remember var? Var is the variable that defines what type of food the animals eat, whether it's a carnivore, herbivore, omnivore, insectivore. You remember? Okay, let's look at it. Unique sleep $sign var. Enter. Okay, so those are the those are the unique values in the var variable, and they are, you can see is the categorical variable. So we want to plot categorical variable. So we said we'll use a bar plot, so ggplot. No, we're working in the tidyverse, so we use our data set first, M-sleep type operator. So var has, you can see it has missing data in it. So we need to remove missing data from it. So we drop NA. But we need to tell it it's from var. If not, it will drop NA from all the data sets. So so we go to our ggplot. So first thing is supposed to be data, but we already have our data. So we go straight into our aesthetics, which is the mapping. So we're dealing with var, right? So var is supposed to be on the x axis. Now, since we're dealing with only one variable, we don't need to put any other thing. So it will automatically assign the frequency of the variable on the y-axis. So we put in our plus sign and go to the next, which is geom. We say it's a bar, so it's a bar, geom bar. That's this second one here. And then we can run this. So that's our bar plot, which defines a single categorical variable. Okay. So we can exactly, good. You're learning fast. We can change the color of the bar to blue. Now, color. I'm happy this happened. When you use color equal to, it affects the border of that shape. Just you can see is the border here that's been affected. If you want this inside to change, you need to use a function we call fill equal to. So let's use fill equal to red. Enter. So we have an outer border of blue, which is the color, and a fill of red, which fills the bars. Now, sometimes you see some graphs that have that orders from the highest to the smallest, or from the smallest to the highest, and the bars look beautiful in that way. So how we do that is we use a function under the forcats package, which we call FCT. So we use that instead of just working on var, we tell R to arrange var first. So FCT underscore, and we want it to arrange it according to frequency. So we said FCT underscore in frequency, click, and then we now write var. So if you run this, you can see it gives you a neat arrangement according to the frequency of the categories. You done? This is what we added, this FCT in frequent. So it's just used to arrange categorical variables. This, so FCT means factor. So factor in frequency. That's what this means. So to arranging the var category in the order of their frequency.
Yes, that means the var variable is already factor class.
No, when you use this function, it converts it to factor class.
Even if it's not.
Yeah, even if it's not before it now.
So you don't need for to be class.
Yeah. Yes. Yes. Okay. So we have seen a single categorical variable. Let's go forward. We'll look at double or multiple. So let me use simple word, 2 or more categorical variables. So let's see. Let's go back to our scheme and see the categorical variables. We see var is a categorical variable. We see genus, we see name, we see conservation. How many unique? Okay, we use var and conservation. Var has 4 unique values. Conservation has 6 unique values. So let's use var and conservation. Go back to our scripts. Okay, so we start with msleep. Type into, so now let's select. We say we're using var and conservation. And then we type that, where are you, M? We drop NAs in them. And then we pipe that in. So, you know, in the previous one, when we wrote drop NA, we put in the variable here. But exactly, so we've selected what variables we need, so we don't need to put them in here. Okay, so we will go straight to our ggplot. We have our data already, so we go straight to mapping and we say aesthetic. And
my data into it again.
You are repeating another thing, and then you've worked on this data by selecting, by dropping any. So if you put in data here again, you're asking ggplot to work on msleep, not on what you worked.
And you still work on it.
Yeah, it will still work on it, but I don't know, it might give error or it might just work on the msleep.
Okay.
But yeah, so we select our 2 variables, right? For conservation. Sorry, I didn't put my plus. So plus, and then geom, we said bar, right? Geom bar. Now, let's see what happens when we plot this. Control Enter. Okay, start counts can only have an X or Y aesthetic. Okay, so it means we didn't need to put two variables here. So what we needed to do here was to, so since we're working with two variables, categorical data, they are used to disaggregate data. You don't really drive data like numerical, you just disaggregate. So now we can do a few things. We can use fill. So this will still give us our var like we've done before, but we're now saying fill it up with the conservation variable. So if we run this, so you can see we still have our var categories the same way we have the other one, but now we have asked R to fill it up with conservation. So within each var, it has categorized conservation. We get within each var, it has categorized conservation.
So this is stack part.
So this is, yes, this is stack.
So because of the fact that this category, the Jumba suggested this stack bar, right?
Yes, it's no, the Jumba told us that, yeah, it says we should do something else. See the error it gave. See, it cannot have an X and Y. It means we cannot have var on one category on one axis and conservation on another axis, because it's only a frequency, a numerical variable that can drive, yes. So that's why it suggested we do something else. So let's go ahead.
Sure, sorry, one question. What does this graph mean? For
So
example,
this graph, this conservation, so for each, let's say these are carnivorous animals. In carnivorous animals, it tells us there is this amount of conservation in it. That's the conservation VU. This amount are in carnivorous. NT, this amount are in carnivorous. LC, this amount are in carnivorous. So it categorizes each category in VOR according to this conversation. Let me do let me work with Star Wars so you can understand what I mean, and use this one. Has too many variables, too many unique values in it. Star Wars, what values are we using now? Okay, Star Wars has eye color, right? Select eye color,
Yeah.
and then gender. Sorry, yeah, gender. Type operator. Let's drop our any. And then ggplot. AES. Then, sorry, what did I do?
Oh my God.
AES. I. Hello? Fill equal to gender. Okay, that's plus Jumba. Okay, so let's run this and see. Okay, so these are the different eye colors. Black, they are like too much. So it's, and I'm happy this happened because there's another function I want to introduce right now because of this. So for each eye color, it's categorized them into male and female. So this is how you represent two categorical variables on one graph.
Okay. I know that, for example, in the first part,
The first bar is black. Let's assume it's just black or black blue. Yes. So for all those that have,
the red is out of the black blue,
yes,
the small amount which the red is female,
yes,
and the large amount
is male. Yeah. Yes, stack. Yes.
Just like, for example, in gray, black, there's only male.
Yes. Exactly. So that is it. So because of this way these names are written, because we have so many variables, this space is not enough to contain all the names. So it leads us to introduce this variable. It's called chord flip. So chord flip flips the x-axis into the y-axis, so you can now have all the colors written neatly here. But it's still the same graph, it just flips it. So you can have the name, the colors of the names of the eye color written very neatly like this. I'm happy that happened to introduce this. Okay, so this is stacked. We could have also done Jumba position dodge. Let me see. Let's mute this and run this and see. Okay, no. In the layer mapping starts Jumba object dodge not found. It's supposed to be in inverted commas. Ladder. Okay, so this is the what do they call it now? Dodge way. It doesn't stack them on top of it just puts them beside each other. So this is another way to represent two categorical variables. So for each, let me flip it so it gives us a better. Put a plus sign there. Okay, so it looks neater like this. So for yellow, there is male and there's female. So previously it stacks them on top of each other, but now it's just by the side, by the side, by the side. Then we can also use position instead of dodge. We can say position fill and run. So now it's a form of stack, but it makes everything 100%. So it's a percentage form of bar. Everything is 100%. So in this place, we have like, in this black, we have like 78% of eye colors black are male, and then another 22% are females, like that. In red blue, 100% are females. So this is another. So we've mentioned the three types. We have the stack, which could be on top of each other or in a field form in percentage, and then we'll have the dodge.
And this one, what you did?
We removed dodge here and put fill. Yeah. Okay, so that's two categorical variables. So let's look at one numeric variable. So let's go back to our MSlip. Now the awake, what's it called? Awake variable. There's an awake variable in MSleep, and it just defines the time the animals are awake. How many hours are they awake in a whole day? So that's the awake variable. So we can just do our ggplot. And then we have our data ready. So we just do our aesthetics, and then we select our awake. And then we put in our plus sign, and then we say for a single numerical variable, we use what? A histogram. So Geom histogram. And then we plot it into enter. So this is a histogram. The difference between a histogram and a bar chart is a histogram is joined together. There's no space in between. And then a bar chart has space in between each bars. But you can see a few spaces here, and those are spaces where there is no data. But there's a way you can adjust for this. You can, under the Geom histogram, you can put in your bandwidth. And let's say equal to 2. And let's make this let's fill here with blue. And let's do alpha equals 0.5. I'll explain that. This is not what I want. Sorry, this is not here. Okay, so you can see R has adjusted the width of the bins in the histogram in such a way that we don't have spaces in it, because I adjusted the width here. So that's what R did, and then it filled it. It's actually blue on my system here, but because of the projector is showing purple. And then alpha equal to 0.5. Alpha, this alpha just defines the transparency of the color that you. So if I say alpha 0.1, for example, you can see it's more transparent.
What if you remove all other?
If you remove it, the default is 1. Is 1, and even if you write it or not, it's still 1. So let's assume I remove it, and we run this. So it gives you the standard color. Yeah, just if this color is looking too thick for you or something, you want to reduce the transparency. And then there are places where you need to introduce transparency because you have multiple graphs on the same thing. You need to see how one line is going behind another. That's where transparency actually functions well. So we can adjust this bin as we please. If we say 4, it will expand the size of the bins. Control Enter. You can see it has expanded the size of the bins. This width is bigger. We can make it smaller. And say 1. It makes it. So basically, a histogram just tells us what the shape of that numerical data is. Why this is important is we need to know if a data is normally distributed or if it is skewed, because it can have an implication when you're analyzing data, whether the data is skewed or normally distributed. So that's the implication of that. So we have seen a single numerical. Let's go to double, two or more numerical. So for a two or more numerical, usually we use, okay, sorry, I'm not done with single numerical. We said for numerical, we can use a histogram, we can use a box plot, we can use a density plot. So let's do a box plot. So it will be the same thing here. Copy. But we'll change this to box plots. Yes. And then remove bin, which is not a argument here. I will remove this field. Okay, so if I run this command, so it gives us a box plot. A box plot, this box shows 50% of our data, because this is the 25th percentile, this is the 75th percentile, so this is like half of our data. And then this line in the middle is the median, that's the 50th percentile. And then these whiskers at the sides are 1.5 times the interquartile range. That's the difference between the 75th and 25th percentile is actually this whiskers here. So that's basically what a box plot defines. We can color it and say, if we write color, red. If I do this, what will happen, Dr. Sohana? Good, the outline will change to red. And then I add fill equal to blue. So this will fill the box itself. So Control Enter. So you can see the outlines have changed to red, and then the box itself has been filled with blue. So that's a box plot. Next, we do our density plots. So I just copy the same thing again, and I paste. And then I remove this and put density. And then I remove this because it's not a function in geom density. Okay. No, bin width is not a function in that. So if I run this, so a density plot is each point in each density plot is just, let's remove the color first. Okay, so a density plot just plots for each point is the probability of that value being at that particular point. So these values are like probabilities, and it ranges like that, like that, like that, like that, like that. So we can fill it if we want, but you can see is a numerical variable, and a numerical variable drives the data. So we've seen histogram, we've seen a box plot, we've seen a density plot, all used to describe a single numerical variable. So let's go to two or more numerical. And for two or more numerical,
I only have 14 minutes left.
yeah, we should be done. We will have two or more numerical, then we'll do one categorical, one numerical, and then two categorical, one numerical, and then we're done. Okay, so two or more numerical is a scatter plot. So we're going to use sleep total and awake. These are two numerical variables in mSleep. So mSleep GG plots. So aesthetics, sleep total, awake, plus June. Say we're using what again, sir? What did we say we're using? What's the name of this category again? Point, sorry. Point, yeah. Okay. So if we run this command, so it just gives us dots. So you can see sleep total is our X axis, awake is our Y axis, because that's what we said here. And then it plots. So we can see they are like inversely proportional. If sleep total is increasing, awake is, if sleep total is increasing, awake is decreasing. So there is an inverse proportionality here. Now let's play around with values. We can add plus Geom Smooth. Geom Smooth is like a smooth line that goes through this point, and then by the side, it gives the standard error of the statistics. So if we do that, and we run the code, it didn't show this right now. This okay, but it just joins them with a line, and then what now? So categorical variables. Okay, let's. So you can see we've been working only on, this is two categorical variables. Let's assume we wanted to add what's it called now? Add another variable, let's say plus one. Oh no. Let's do one numerical and two, sorry, one categorical and two numeric. So with this two numeric we have done here, we can bring it and add one categorical in it. Copy. Paste. So we can categorize it by var. Let's see. And there are different ways we can do that. We can do, for example, plus, we can do facet wrap. Tilde var. Control enter.
Minus.
Sorry?
Minus.
No, not.
Oh,
No,
okay.
it's tilde, T-I-L-D. Yeah. So you can see it has categorized these two numerical variables by var, and we use facet trap. Facet trap, what it does, it's divides them into different graphs. So there is the carnivorous category, herbivorous category, omnivorous, insectivorous, and then it also included our missing data. So we could have dropped missing data before entering here. So let's drop missing data here. So drop any var, and then we pipe that into Blab. So we run this command again. You can see now we have only 4. It has removed the missing data part. So this is one way to do this. We can also say, instead of this geom smooth here, we can put geom line. And let's say we remove facet trap and remove this plus here and run this command. No, there's a place where I want var to be. For geom line. Aesthetic. I hope this would. Aesthetics color equal to var. Okay. This is 2 numeric and 1. No, this is not why I want this. Sorry, let me do something. Sorry. Let's use the points for this. Okay. Control Enter. This is still small. Let me increase the size of the points. Let's use size. Yes, madam.
You mind sending me?
Okay. Yeah, I will send you.
Thank you all. See you next week.
Okay.
And you.
This is not looking as good as I want it to look, but it has categorized the points by the var variable. You can see the canny has small, heavy is bigger, insecty is bigger, and then this. So it has done that categorization here. But all I'm just trying to say is you can represent 1 categorical and 2 numeric in that format. Then we can also use a box plot to do this. So box plot. Let's remove this geom line here. And remove this here. And let's run this command. Where did all these things come from? Okay, I use size. Okay, fine. So this is 2 numeric, sleep total and awake. But it has categorized by 1 variable var. So this is the carnivorous, herbivorous, insectivorous, and omnivorous. So that's representing 2 numeric variables and 1 categorical variable. Then the last one we're supposed to do is 2 categorical and 1 numeric. Two or more categorical and 1 numeric. For this one we've done before, we can also use what's it called? Density plot for it. Let me do okay. Backspace. Paste. So let's assume we change this to a density plot. Density. And we run it. This is not what I want. Room density. Okay, let's do it somehow. Let's see what this gives us. Geom density requires the following music aesthetics. Why? Oh. Why is this? Am I not getting this thing now? Sleep, tutorial, awake. Okay. Okay, so it's supposed to be. Okay, feel go to 4. Let's see. Beautiful. This is what I wanted to show us. So this is 1 numeric and 1 categorical variable using a density plot. Now, Bash, you can see this first graph. Because it is not transparent, I can't see what these lines are doing behind it. So that's where that alpha becomes very useful. So alpha equal to, let's say, 0.4, and we run this. So you see, we've made it transparent. So we can now, we can now see how the other lines are moving. But sometimes also this is not too clear. So we can just do a facet wrap so that we can see all of them differently. Facet wrap by VOR. So facet wrap just separates all the values in that category. So this is only Carni, this is Heavy, this is Omni, this is Insecti. The graph we just saw earlier now joined all this 1, 2, 3, 4 within one canvas. So but facet wrap separates them into different graphs. That's what it does. Okay.
These colors
no, because I used it in the ggplots. Listen, I use fill. I fill them with the VOR category. So you can see that's why the density plots, each of them are filled different colors to differentiate them with the VOR category. Yes. Yes.
So the x-axis is sleep total.
Yes, sleep total.
and it just automatically gave the y-axis density.
Yes.
But we determine the field involved.
Yes.
So you make decide which one stable.
The graphs, no, except maybe you want it to be in an order. If you want to be in an order, then you can introduce what's it called now? You can introduce factor infrequent. Let's see where we'll introduce that here. Will it work in this place? Let me see. Mutate. For equal to FCT infrequent for, and then we pipe that into. So let's see what happens. Okay, so here it has given some kind of order to it, but we will not really appreciate it that much, except if, okay, like when we did a single categorical variable. Let me remove this. Requires an X. Oh, sorry. Var. Okay, so this is the var category, just in a simple bar chart. So we want it to be grouped in an order, either from ascending to descending, or but want an order to it. So we can introduce that stuff here. Instead of just writing var, we tell it. So we use this FCT is factor. Factorize the var categories in frequency, and then we run this, and then it gives us an order. Okay, I think we should stop here.
Thank you very much. We will have more.
Mike is not going to be around tomorrow. That's one.
Wow.
I think it's over.
No. Just an analysis. No, yeah, because initial plan was just to finalize on Friday. We're changing the date. Is there a subject, an agenda that's not scheduled?
Yes, we didn't do analysis.
I think
We didn't do analysis.
what do you think?
Well, I can do a small video on that and send to all of us. That's an option. Next week. I don't know when next week.
The week
Sana is coming back next. I only have 1 day.
Yeah, that is for me that preferred.
Preferred option. Okay. So so that we can practice on these ones. The analysis is not really too technical, like all these ones you've been doing. Analysis, once you also need to manipulate data and then pipe it into the test that you want to do, whether it's a t-test, ANOVA, whatever, chi-square. So you need to do all these things we've done and then pipe it into the test.
And like, for example, I am interested in the analysis, for example, games, analyzing the games and making like more principle or like a less stable.
Yes, yeah, we can also do that. That's the janitor package. We didn't really dwell much on that, where you use the Tabyl, TABYL, and then it has those add-on packages that you can use to beautify your tables. We can include that next week. Yeah. So that and the analysis. Okay, thank you everyone today. Bless you.
So we'll do the assignment.
Yeah, please try and do the assignment.